Hi everyone, Wayne Hilliard here down in the laboratory, the cellar, for what it's worth. Wanted to do a quick channel update where I'm at. I posted a video about using an autocollimator to measure a straight edge a couple months ago. I've meant to get back, do an update video on it, and if you read the comments down below, a couple gentlemen have commented on it. One, Ron, he suggested that I do one with the straight edge tipped up on edge on the surface plate, as in using the actual surfaces like you would be checking for straightness, and then measure that with the autocollimator, and then put the straight edge up on its airy points, and then do the measurement. And I'll be saying more about airy points in that video, what they are, what they're used for, and the concepts behind them. So I'll save that for when I do that video. So I intend on doing a video with the autocollimator measuring the straight edge in those two positions as Ron suggested. I meant to do it long before now, but as you'll see in this video, I've got a couple segments that I've done showing different projects that I took on in the last 2 months, which is one of my flaws is attention. I think I had some level of attention deficit disorder, because I get interested in something and then I'll pursue it for a while, and then something else nice and shiny and glittery will catch my attention and I'll run off and do that for a while. Most of the times I circle back around and pick up the projects where I dropped them and move them on. So it can take me a while to finish a project, sometimes years. But hey, you know what? This is supposed to be fun, and if it's not fun, then why do it? This isn't a job for me, so I don't want to make it like a job. But I do want to. I want to try to grow my YouTube channel, and I would like people to enjoy looking at my videos and the stuff that I do. Comment. I mean, I certainly, all this stuff I'm an amateur at. I do understand a lot, but there's a lot I don't understand. And so if you happen to be a professional or even a gifted amateur that have used different things that I show in my videos, constructive criticism is definitely welcome. You can give me constructive criticism all day long and I'll take it, because I want to learn and I want to get better and I want to do this stuff. Anyways, I think I'll wrap this introduction up, and then over the next couple days, this is now February, I don't know if it's 27th, 28th, towards the end of February anyways. And before, probably by March 1st, I want to have this video up on YouTube, an update, channel update, and see, and then start working on the straight edge video, doing that, getting that over, and seeing what the results are. And I'll have more to say about that and precision measurements when I do that video as well. So with that, I hope you enjoy as much as possible this channel update, and I thank you for watching. Thank you. It's very encouraging to see hits on a video like this autocollimator one. I mean, I'm nowhere near the level of the hits that some of these other gentlemen have, but still, it's very encouraging to see people watching it. And if you don't comment, give a thumbs up or a thumbs down, or whichever. I mean, if you do a thumbs down, actually I would like a comment. Either way, I mean, if you do a thumbs up, tell me what you liked about it, so I could maybe focus more on that area. Or if you don't like it for whatever reasons, again, constructive criticism, let me know what you don't like. I would like to develop an audience of some level. So anyways, with that, I'll get on with the compilation of this video, and I will see you on YouTube. Bye. Okay, so about a month or so ago, actually right at the end of December, one of my other interests, as I said in the previous video, was optics. and in particular I've been investigating spectroscopy, both fluorescence and absorption spectroscopy, and I was looking for a diffraction grating, and I ran across one on eBay that I wanted, and it turned out that it's a gentleman who runs a surplus business over on the other side of Vermont from me, about an hour and a quarter away, was selling it. So rather than ship it, I decided to drive over and meet him, and then pick up the diffraction grating. When I got there, he threw a couple of offers my way, which I couldn't turn down, I should say. So this one here is a jig transit. He had this one over there in pieces, and it was pretty much intact. Now, I mean, this does fit in with the whole machine alignment theme of these videos. The jig transit, for those who aren't familiar with it, a jig transit is a device that allows you to set up planar surfaces and inspect planar surfaces, both vertical and horizontal. It's very, very accurately aligned. The optical axis is aligned very accurately with the pivot points in the center of the instrument, so you can focus literally on something 6 inches away from the end of the transit, and then as you turn your focus knob and zoom out to infinity, everything will stay directly in line with the optical axis. So you're able to inspect points, both, like I said, from like something like 6 inches from the jig transit to out to infinity. Realistically 20 feet, 30 feet, something like that. Now the other feature, now of course this isn't like an engineer's transit that has setting circles that show elevation degrees and azimuth degrees. There's no scales on it. This isn't to measure angles. This is strictly to pivot this. Let me loosen this locking knob up. Pivot the transit up and down, which will let you inspect a vertical plane, and then let me unlock the other one. Turn it on its axis here and inspect a horizontal plane. This also has in it a telescope that goes through, an alignment scope that goes through the pivot point of the jig transit. What this allows you to do is you can set up a target off to the side and set up an accurate 90-degree angle, reference angle off of this. So normally these things, you find them on eBay for anywhere from, you know, $400 up to a couple thousand, depending on what's included with them for accessories, etc. Well, he had this one sitting over there, and he let me take it for $25. Well, I couldn't turn that down, so I picked the thing up for 25 bucks. Hell of a nice guy. Andrew Smith, his name. If you go on eBay and look for AMSL is the seller's name. It's mainly scientific equipment. He does have metrology equipment. He has laboratory equipment. He has, that's pretty much it. He buys up the stuff up, I guess, when they're going out or auctioned off, and he parts it out or sells the equipment whole. This one he was parting out, but then he said, you know what, he's got several of these, and if I really wanted it, 25 bucks. So I brought it home, put it together. He was kind enough to send me, it came with one eyepiece, no eyepiece for the alignment scope in the center, and then a couple weeks later he sent me a package with a note saying that he had forgotten these two things in, which is a right angle eyepiece for the jig transit, which allows you to get up closer to things and tip it down, so you make it a little more easier to look through, and another eyepiece that will allow me to set up the telescope in that direction. Very nice guy, no charge. Had just sent him over to me so I could complete the the jig transit. So that's project one. I haven't done a lot with that. I have put it together, played with it a little bit. My main focus is this other piece of equipment, which is over here. Let me, did I just lose the light or something? Boy, it seems like it got dark in here all of a sudden. What the hell's with that? I guess, weird. I don't know, let me move over here, at least get some light. Okay, so what this is a Guilford Labs spectrometer. Absorption spectrometer does absorption measurements from UV spectrum, visible spectrum, into the near infrared. So I've been working with this. It was pretty much the section of it called the monochromometer, which is the section that breaks up the light and scans the different wavelengths across the exit slit, called the monochromometer. That was intact. It has a fused quartz prism in it. They use fused quartz because glass or plastic will absorb UV radiation, whereas fused quartz passes it. So this doesn't have a functioning deuterium lamp in it right now, which is your UV source. If it was, I could do UV spectroscopy from like 200 some odd nanometers up to the 400 nanometers up to the edge of the violet spectrum. It originally was a manual instrument where you would have these two dials. This is your wavelength adjustment. This over here is your optical slit adjustment, adjustable anywhere from 0 to 2 millimeter optical, both entrance and exit slit. Originally I had a photometer over here. When I got it, I should say he let me take this for 50 bucks, which again was I couldn't turn it down. Didn't have a functioning photometer on it. Somebody had taken some stuff out of this. They'd taken the original tungsten lamp out of the light source and back, and they had taken the photometer off. So I had to, so I bought a photomultiplier tube from AMSL, and had the machine up a mount to get it mounted to the spectroscope here on the end. Won't go into great detail photomultiplier, but basically what it is, it's a vacuum tube, has a high voltage source, about 1000 volts, and how it works is it's meant to be used in total darkness, and when a photon of light hits it, it sets up a cascade of electrons down through the vacuum tube. Still the most sensitive detection devices there are. They still use these, even though it's a vacuum tube technology. They still use this technology to this day. It's so sensitive. It's insane how sensitive it is. So I built that up, and have been playing around with mounting a stepping motor on it to run so I could do a powered scan. And it's still breadboarded together for the most part. Under the voltmeter is the 1000 volt power supply, and that's the 24 volt power supply to power the 1000 volt power supply and power the stepping motor. Stepping motor, of course. That box right there is a USB oscilloscope I use for troubleshooting. Down here is some circuitry I built up. It's a transimpedance, they call it, amplifier, or current amplifier, which takes the current source from the photomultiplier tubes and amplifies it converts it into a voltage and amplifies it. And then I'm recording it on an Arduino Uno down here. I use that to read the data off an analog to digital converter and log it and then do some graphing. So basically this has been taking up the bulk of my time for the last month and a half, and I'm pretty close to a good breaking point on it where I can step away from it and focus on something else for a little while. So what I'm thinking of doing is going back over here and doing the straight edge tipped up on the surface plate with the autocollimator, and as Ron wanted me to do, and we'll see what the results are. I'm kind of interested myself. So anyways, with that, I'm going to conclude this. Like I said, it's going to take me a while. I'm going to try to start the video today, doing the setup and doing some testing. Probably take me a couple weeks working at night to process the video and get it into somewhat of a reasonably consumable format for YouTube. So with that, we'll talk to you soon. Bye. Okay, so this is my Michelson interferometer that I've been playing with. This is another project that's been taking up time. Now this is interesting. Why do I have a battery flashing at me? Well, let's hope it continues. Yeah, so this is my Michelson interferometer. This is kind of figuring into the whole precision measurement scheme because I want to, one of the uses of Michelson interferometers is to do very ultra precise linear dimensional measurements on the order of nanometers. Yeah, that's like billionths of a meter. So yeah, so I've been hacking this thing together. I'm still working on it. I'm going to make some mounting blocks, I guess, and you know, this is a beam splitter cube down through there. I don't know, that didn't focus too good. Maybe it'd be better if I do this. Zoom in like this. I don't know. I'm using my DSLR as a video recorder because I have my other video camera set up over here on a mount that I'm actually going to do a short video of the fringes that I get from this thing. But I just wanted to give an overall update of what this thing is. So that's a helium neon laser emitting red light at oh boy, I'm gonna have to double check my numbers here. I know it's 638.5 nanometers. I'll have to look it up. I probably misspoke. But the wavelength of the light is extremely well known, and it's pure monochromatic laser light. And this is just a little optic that I picked up at a swap table at Stellafane one year, using it as a kind of a beam expander right for now, just to kind of play with. That's a cube beam splitter to split the laser light into two pieces. Very similar in the autocollimator video. I talked about the beam splitter. Well, this is a beam splitter. This is a beam splitter, and I don't know how come my autofocus doesn't seem to be working. I wonder if can I zoom in on this and focus? Yeah, here we go. I'll have to do a little bit of a manual. So this is actually a linear beam splitter made by Hewlett-Packard specifically for interferometers, and that takes the laser light, and as you can see, I've got the beam splits into two parts. One goes over to this mirror on the left hand, and then this one, if you look, you can see the red dot on that one. Then these reflect back in them and gets recombined in the beam splitter. And let's see if I can catch the beam. Right there's the beam coming out, and I'll show you the fringe pattern I get with this other video camera. So this is another project that I've been working on that's kind of been taking time away from my videos. I really need to get back to work on the straight edge autocollimator project. Wanted to do that and show, as I mentioned, Ron suggested I do a test with it up on edge on the surface plate, and then one with it up on its airy points. And I'll have more to say about airy points when I do that video. But anyways, this is like my third project that I picked up here, and I want to get to the point where I can do count fringes, which is basically how these things work. You'll see more. If you're not familiar with interferometric fringes, you'll see some in a video here attached to this that I'm going to edit together. So with that, I'm going to run, and do the video with the fringes, and then at some point hack this whole thing together in one
so we're
longer
looking
video.
at the interference bands in a Michelson interferometer, the one that I showed in the earlier video. And just wanted to show you what they look like, and if you haven't seen them, I mean, a lot of people are familiar, but some people aren't. So, and hopefully this video will turn out okay. It's difficult to do this video like this because of the I do get some light, camera sensitive. I'm trying to get as much contrast as I can with my bands. As you can see, if I this is just me tapping my finger on the surface plate, and I mean very lightly. I'm not hitting it all. Can't even hear it. And if I stomp my foot, you can see it blur out from the vibration in the concrete floor. Very sensitive. I'll let you read about Michelson interferometers, but basically one application for them is doing precision measurements. And now this light wavelength is, and I forget the exact number, it's 600 and some odd nanometers. So that means the distance between those black bands. I'm going to take my finger and just gently press on the end of the translation stage. I mean, I have this on a translation stage with a thousandths adjustment, and forget turning it. I mean, if I try to turn it, which I'll do right now, you can see they just go all over the place, and then if I turn it a thousandths, it's gone so far I need to come up with a better translation stage. And so right there, I'm just gently touching it with my fingertips, and you can see the fringes move. Now how you do it, measurements, is you actually have a detector that will detect those dark bands as it goes by, and you count them. And with the number of bands that move, you can then multiply it by the 600 and some odd nanometers, and that will give you the distance that this translation stage has moved in linear distance. And this is how the recent LIGO's experiment measured the shrinkage in the what is it, like a 4-kilometer leg of it's some insane amount that the gravity waves changed the arms in the Michelson interferometer. The dimensions and the numbers they came. You really Google LIGO's gravity wave and watch some videos about it if you haven't. Very interesting, awe-inspiring, just insane the numbers they're talking about for distance. I mean, I'm talking small, well below nanometer measurements that they're doing. So pretty cool stuff. Well, anyways, these are the fringes. Hopefully this video will be good enough to view. It's not going to be great because, like I said, it's very difficult trying to video this stuff with a video camera that I'm using. I can use a dedicated sensor a lot better and get much better videos and stuff, but I don't really have one going right now, and I didn't want to try to do it for this video. Hopefully that this stuff would be good enough to give you at least get an idea of what fringes look like and what they are. So with that, I'm going to close this up and start compiling this all into a video for YouTube. Thank you. Bye.